Ladies and gentlemen, thank you and welcome to our open house and ribbon cutting of our new facility. My name is Mark Allen. I am the mayor of Washington Terrace City, but more importantly, I'm the chairman of the board of trustees of this fine facility. And it's an honor and a privilege to speak to you this afternoon. It's been a long road, over 3 years, watching this project, and it's just been wonderful. But it's finally done. I went through it about 3 weeks ago, and it's amazing.
This has been a great project for us. Most of us who started off as environmental engineers did so because we wanted to do something good for our communities, something good for society. And this is really one of those really great things that we're able to do, working in partnership with the folks at Central Weber Sewer Improvement District to deliver this facility. So I simply wanted to say thank you to Lance in particular for your partnership approach. I think that was the key to getting this done, getting it done well. And I want to say one other thing to you, Lance. This is the cleanest plant ever. Well, I've been to Germany, I've been to England, I've been to Australia, I've seen plants all over the world, and this plant is just fantastic. You've done a great job, and congratulations. Last thing I'll say is we stand behind our work. If there's any problems, you know how to find me.
I'm John Saval with MWH Constructors, and as we celebrate the completion of this project, I also wanted to celebrate the effort that it took to get us to this point, and that was quite significant. First of all, it took a lot of time. We started construction in the fall of 2008, and the major construction was done this past fall, 3 years to construct the improvements that hopefully you'll have a chance to go see. Second of all, it took a lot of material and labor. I always like these type of statistics when we talk about a project. We placed over 60,000 cubic yards of concrete, 9.5 million pounds of reinforcing steel. We moved over 250,000 cubic yards of soil. We lost count of how many miles of conduit and copper wire that we've installed in this project. Throughout the course of the project, over 1,200 people were employed on this project, totaling almost 1.4 million man hours. So if you think about the economic impact of this area from this project, it was substantial. Third, we had an absolutely outstanding team. Our design team was led by MWH Americas. Lee Fisher helped us with the process design. The HVAC and electrical substation was designed by Heath Engineering. Outstanding architecture work by Braxton and Christopher. It's hard to make a wastewater treatment plant look nice, and I think they did an absolutely outstanding job with the architecture out here. And all the instrumentation and controls was by SKM. Absolutely outstanding design team. Our construction team also was excellent. We had over 24 subcontractors on the project, 11 of them what we considered our key subcontractors, and I'll just list them. Whitaker Construction, Alder, Bodell, Gerber, Skyline Electric, Wasatch Electric, United Team Mechanical, SKM, Post Construction, DeBerk Brothers, and Envision Mechanical. And finally, what makes a great project is a great owner. Between the Board of Trustees, Mark Allen, Lance Wood, John Corden, Paul Higgins, the project manager on the job, Scott Hakes, and then the plant operators, Jeff Kingston and Scott Hess, absolutely outstanding. And the thing that was nice about this owner's team is they knew what they wanted, and they were able to communicate that very clearly. There was alignment between the Board of Trustees, the project manager, the operations staff, which we as designers and builders appreciate when you have alignment up and down the project. When things got tough, and we had a few bullets to avoid on this project, we had great leadership out of the owner's team, and we really appreciated that. So in summary, our motto, MWH's motto, is building a better world, and we really believe that, and we really appreciate the opportunity to build a better world here for Central Weber. So thank you.
we'd like to cut the ribbon, and I'm going to ask that the entire Board of Trustees help me cut the ribbon. They haven't done anything today, so I'm going to make them be involved here too. So let's go down there. Let's all cut that ribbon, okay? Okay, we're ready. Okay, 1, 2, 3. 1, 2, 3. Hey! Hey! Your first shot. It worked.
This is the septage dump station. This is where the septic haulers that get product, they come and they dump in here. Everything's done off of weight, so they just pull in and the truck's initially weighed and then they dump, and then it's finished weight and everything's charged by weight now. This is the grit truck where grit and our bar screens, everything that's inorganic will dump into the back of that truck. It's one of the less technical parts of the sewer plant. This is one of the smellier portions of the plant because this is where all of the raw material is. These are our front scraping bar screens. We've got 2 channels. Each bar screen is capable of 60 million gallons a day. So the influent runs through the bar screen, and anything that is caught on the bar screen, rags, mostly inorganic materials, just scraped up the bar screen and dumped into that trough. And there's sluice water that we take out of the wet well that will push the screenings down into the wash compactors. And the wash compactors use a screwing motion with water being sprayed on them to dump the organics out, because we want to keep as much organics in the plant as we can for our aeration basin and to do the rest of our process.
Disposable diapers.
Yeah, this gets pretty much the inorganic stuff that is flushed down your toilet or down the sink. Yeah, diapers, rags. It dumps down, goes through our wash compactors, and they're really pretty efficient. The incline conveyor probably runs like once an hour, but it doesn't dump nearly that much, but it takes those screens, it really compacts them, and then it dumps it in the back of the truck.
It just goes to the landfill.
And then, yeah, that all just goes to the landfill. That's everything that's inorganic. The grit classifiers, there's actually these grit Vortex units outside that the grit sinks and separates and is pumped upstairs through the grit classifiers, which also there's spray nozzles that clean all the organics out of the grit.
So you capture that?
Yeah, so we capture the organics and put it back into the system, and then the grit's just conveyored down and dropped into the back of the truck as well. The new plant's way more efficient because obviously it was built for this time, where that plant was built in the 50s or whatever, and it's still very efficient and cleans the water well. But this one just does it more efficiently. We'll just head out through the grit classifiers and then we can go look at the raw pumps. These are the grit Vortex units. So the channel comes in here and it creates a vortex, and that gives the grit time to settle. The grit slurry pumps pull out of a trough that's in the bottom of these grit Vortex units and pumps it upstairs to those grit classifiers. And that's how it's all separated here.
So getting that grit out helps save the pumps?
Yeah, it helps save the pumps, and it's also inorganics. These are our big fans for the influent channel. They're just exhausting the channel so that there's no buildup of any kind of gas, or they help with smell. Those are those actually open, and the influent pumps are right below there. That's how, if we ever had to take one of them out, that's how they would access them, is with a crane, and they'd have to pull them out. This is the electrical room just for this headworks. Each piece of equipment has its own disconnecting means and somewhat control from here, and it also has a local control panel where you're able to control the piece of equipment locally. That's all just cable tray. That's all of the wire and stuff that's going out to all of your various equipment. And these are our influent pumps. They're 350 horse and they'll do about 21,000 gallons a minute. Each pump's capable of doing 30 MGD, so this headwork's built for expansion. I think this headwork is capable of handling 2 more phases, more clarifiers, more aeration basins, and more secondary clarifiers and chlorine contact chambers. So these pumps are pretty impressive. This is so deep that there's a lot of weight to be supported. And so the floor is actually thicker than even this, than the ceiling. So. It also helps with settling, so there's not nearly as much settling, you know, pouring the concrete thicker.
How many gallons of waste come through here each day on average?
On average, I would say it's between 30 and 40 million gallons a day.
Wow.
There's, you know, times that it's less, and then there's times during like a storm event that you would get way more. Yeah, infiltration from some of the other stuff. So that's why it's good to have the capability. So with these 3 pumps, we would be able to, well, the plant's only designed for 60 MGD at this point, and then the other plants will also handle 60 MGD. So at this point, we could safely do 100 MGD. Then there's also room for growth. Once it leaves the headworks, it comes down to this primary splitter box where it's then evenly distributed to these 2 clarifiers. These are our primary clarifiers, and they settle out the heavier solids, and they actually settle down, and there's a scraper on the bottom which scrapes them into a hopper, and from that hopper it's pumped with our raw sludge pumps over to the blending tanks. So all of our your heavier settlable solids are removed here, and then what leaves the primary clarifiers and heads to the aeration basin is more of the dissolved solids and organics that are left in the water at this point. The arms that go around, they're removing the stuff off the top of the water. The stuff that floats that doesn't dissolve in the water is actually scraped off and scraped into a scum pit, and that's also pumped over to the blending tanks. They put everything down in the ground because it helps so that the pumps don't have to pull it up to pump it.
Oh, okay.
You know, so it's more efficient. So these are the raw sludge pumps. You've got a pump dedicated to each clarifier. They're all on timers so that it pulls the sludge from each clarifier at timed intervals so that we can keep a uniform concentration being pumped over to the blending tanks. The subnatant pump, that little one there on the end, that scum that scraped off the top, that just pumps the water off the bottom of the scum back to the splitter box. And then just the scum is pumped over to the blending tanks.
Is that a grinder inline?
Yeah, that's an inline grinder. So after it leaves the primary clarifiers, it comes into this splitter box, which evenly distributes it between however many basins are in service. And right now we only have 3 basins in service. This first zone where you don't see the fine aeration is our anoxic zone, and there's no air in here. The first zones take care of different things than the ones that are under aeration. And they keep this stuff from settling because the sludge and the bugs that eat the sludge would actually settle if they weren't being mixed. And so these keep it somewhat mixed up until it gets over into the aerated part of the aeration basin. So as you go through the aeration basin, you have more diffusers to less diffusers. So you start here and you've got a lot of diffusers in the first, a few less in the second, and even less in the third. And the bugs use the air to help them reproduce, and they also eat the stuff that's left in the wastewater. So the bugs reproduce, and so our actual MLSS goes up every day, and so we've got to waste some of the stuff that we make. So realistically, we're farming bugs for sewer removal. Everything's returned, so once it dumps off the end of the aeration basin, it goes to the secondary clarifiers. The secondary clarifiers, it allows everything to settle, and the stuff that settled down to the bottom, which is all the bugs that we're using in the aeration basin, gets returned back to the front. And so we we only waste what we want to, and usually we find a number that we like to be at, and then we waste, you know, what's being grown, kind of. These are the secondary clarifiers. It's the same concept as the primary clarifiers. It comes up in the bottom, and then the detention time gives everything time to settle. The settled stuff either is wasted to the thickening building or returned to the front of the aeration basin so that it can make its path again. So pretty much by the time it comes over the weirs of these, it's clear as it's going to get pretty much. It heads to the chlorine contact chambers where any residual bacteria and whatnot's going to be killed by the chlorine. And these are the chlorine contact chambers. We have 3 of these, three separate chlorine contact chambers. The chlorine contact basins are 158 feet long, almost 12 feet wide, and 13 feet deep. It takes about an hour for the water to make a complete pass through the chlorine contact chamber. This is pretty much what goes out into the canal. This is our effluent product. The blower, the peak airflow is 22,815 SCFM, and it's a 700 horsepower blower. And we've got 3 of them. These are what supply air to the aeration basin. Right now we're running one at about half speed, and we're able to take care of the flow for right now. This building was built, as you can see, for even room to grow. In the summer we tend to not have to run our MLSS, which is pretty much our bugs, as high because they're more efficient in the summer. They like to be warm, and in the winter we have to run our MLSS a little higher, and when we run the concentration higher, the blowers have to run harder. But they are very impressive. Our generator sits back in there, and this is all of the switch gear for all of the different buildings. So when the generator kicks on, this is what transfers power to all of the different buildings. This section here, this is the blower section, which controls all of the high voltage on the blowers. And then those are, that's the MCC for that aeration basin, and then some of the smaller stuff in here. But this is our 2 megawatt generator.
Whoa.
And this generator will easily take the load of this new plant. And then as you can see, we've got space for one more as we expand and get bigger. Once it starts up, it sucks a lot of air. It needs a lot of air to breathe. So those dampers open. It'll actually sync with utility. So when the power goes out, we have a little bit of a glitch. But when the power comes on, it'll actually sync with the utility power so that we don't have a glitch when the power comes back on,
So it's
which really is,
seamless.
yeah, it's just a seamless transition. These are the booster water pumps. They're what help us keep the belts clean. They're high pressure washers down underneath that as the belt goes around, it's continually being washed. So what happens is once it settles in the bottom of the clarifiers, it goes through the return line, and the waste line actually pulls off of the return line. Whatever we want to waste that day, that's what we can pull over here. It's not thick enough yet. There's a lot of water in it. So we use these to thicken it up to the concentration that we want to put into the digesters. We use liquid Palmer, which is a liquid coagulant, and we mix it with the sludge, and that's what makes the water drop out of it, and kind of, you know, how it comes in water and then it ends being more just thicker. Not totally dewatered, just thickened up a little bit. And then it falls down into a hopper that's down in the bottom. That plating just helps so that the splatter isn't nearly as bad. And then those pumps that are on the back side pull from that hopper and put it into the blending tank. And that blending tank just mixes all of the different sludges from all of the different directions together so that we're feeding a more uniform sludge to the digester. And that helps with like the gas production and heating and all of the stuff which takes place. Yeah, these are pretty impressive. I mean, that arm right there tracks the belt to keep it centered, and it puts pressure, you know, however you can see it moving, and that just aligns the belt. That keeps it straight. Yep. when we tested these out, they tested out at 500 gallons a minute, so they're capable of a lot of sludge. We try to keep things as clean as possible. We like to keep things neat and nice. So these are the thickened sludge pumps. Once it comes off of the belt thickener, these pumps pump it over to the blending tanks, and then from the blending tanks, those pumps pump it over to the digester. This is our Palmer mixing system. This pump here takes our straight Palmer and it dilutes it with water. We're actually running at 1/4%, and it dumps it into that aging tank. Those aging tanks we use to, the Palmer actually becomes more charged with age. So we let it age for a little bit, and then the Palmer metering pumps are what pumps it over and injects it into the front line. These pumps here, there's one for each blending tank, and they're what pulls the sludge in and actually mixes it up in each blending tank. These two pumps here is what takes it from the blending tanks and pumps it over to the digester. And everything's timed and on cycles so that everything's somewhat uniform. We're sending the same amount of stuff to the digester at all times. Go out here and look at the blending tanks and the digesters. These are the blending tanks, so this is where all the sludge ends up before it goes to the digester. Those Von Chopper pumps keep it mixed up. You actually produce some gas in here, so there is some gas that's fed over to the generator. These are our primary digesters, so this is where it goes. This is where the fresh sludge goes, and the detention time needs to be about 30 days at 98 degrees to kill all of the bacteria that we don't want. Like I said, it produces gas, and we use that methane gas to run our generators. Once it leaves these primary digesters, it actually gravity flows over to our secondary digester, which is that white cap. We use that for gas storage, but from there it's pulled into our dewatering building, and that's where we dewater it to the point that it's more of a cake type material, and that's taken out to the drying bed.
And that's where you dry it out and turn it
Yeah,
into
dry it out and
compost
turn it out, and then
material.
it ultimately ends up in compost, and it has to actually sit out there for 2 years before they can make it into compost, and it's tested every month so everything's dead by the time it's actually made into compost.
And then you just mix it with organic matter?
Yeah,
make the
wood
compost
and
wood
yeah,
chips and stuff that you have.
the clean organic matter
Yeah.
that they pull in, like
Yeah.
trees and manure. A public, they're always welcome to come out, and any of us can take them around and give them a tour.